This is AP Calc notes for section 5.6. We're going to be dealing with inverse trig and the derivatives associated with that. So our intro, first of all, how do we start? By finding the secant of 3 pi over 7. Well, if it's a secant, that's the same thing, and if I need to use my calculator, it's the reciprocal function. Now the reciprocal function is different than the inverse function, because this is reciprocal. If we do the inverse, that means we're switching x and y around. And so getting into the inverse trig functions, if I take y equals the inverse sine of x, that's also the notation that we use is the arc sine of x. And so what we want to do is switch x and y, but if you notice we have a little bit of a problem here. And the problems associated with our domain. So if I take the sine and I want to graph the inverse, so I just switch x and y around and I graph this, this is what I end up with. Problem, this is not a function. And so since this is not a function, somehow I had to limit my domain of my original function so that my inverse function would also be a function. And if you look here, my domain is going to be, for this blue one, which is the inverse, it's going to be from -1 to 1. And then to spit out one value, I got to get rid of all this stuff. And it's going to be here, negative pi over 2 to pi over 2. That would be my range of my inverse function for the sine. And if I can, I think I can do this, y equals sine inverse. No, I don't think I can. So I couldn't do that on the computer, but if I put this in, here would be my inverse function now, and it stops right here. Doesn't go any further. Stops. And so my domain would be from -1 to 1, and then my range would be from negative pi over 2 to pi over 2. This should be a y. Okay, so put that in. If you need to pause this at any point, please pause this at any point. Now we run into the same trouble with the cosine, so I'm going to limit it. Where is it strictly increasing or strictly decreasing? That would be from 0 to pi, so that's the only piece that I'm going to use for that. And then the inverse tangent, well, it's just going to be one of these. If I used all of them, then it wouldn't be the inverse would not be a function as well. So I'm just going to use one of these pieces. So I'm going to put these in and come back to you. So to finish this up, the inverse cosine is the x value is only from -1 to 1, and the y values would be from 0 to pi. So here's my y value, 0 to pi. I didn't do a great job with this graph, but that's how it ends up. You can do these on your calculator as well and just type in the inverse cosine. You can't do cosine to the -1, but it's the second cosine button. And then here's the inverse tangent here as well. You should know those graphs from pre-calc. What you want to do now is probably pause, and you should be able to use your unit circle knowledge to find these inverses. Number 4 gets into the calculator, and then answer the other ones. So go ahead and do that now. Okay, now this number 5 is a little bit tricky. You may have already looked at it, but you should be trying this on your own. Arc secant of 3. Well, what happens with this one is that you're doing an inverse function. So you have to take this value right here, which is the value of the secant at some angle measurement. And what happens with that, that's going to be the same thing as having the cosine of 1/3 at some angle measurement, that same exact angle measurement. So you actually have to reciprocate inside and then apply the arc cosine or inverse cosine. B is not correct because of the inverse functions, and so it's very different than, well, it's just you're doing things in reverse order for this process here. So this is different than this one. Okay, so what for number 6, this one has a cosecant value of -2.1 at this angle, which means that it has a sine value of 1 over -2.1 at this same angle measurement. So you get this value here. Okay, then the bottom ones, we've done this in pre-calc, you're going to build right triangles. So we can evaluate these things by building a right triangle and sorting some of these things out using SOHCAHTOA. if I take this, you take your inside information, which is arc cosine, and you build a right triangle with that. So if I build a right triangle, and you can do this pretty much the same way every time, put a theta there. You don't know what the angle measurement is, but you call it theta, and then this is the right angle. Then build it with the cosine. Cosine is adjacent over hypotenuse, so adjacent to this angle measurement is going to be the 1. The hypotenuse is going to be 3, 1 over 3. And then I go ahead and find this missing piece. Since it's a leg, I take the hypotenuse squared minus the leg squared, which would be 9 minus 1, so it's the square root of 8. And then I read the tangent off of this. So the tangent is opposite over adjacent. So now I'm using the outside function to read. So it's going to be the opposite of the angle measurement, which is square root of 8, divided by the adjacent, which is 1. So this would be 2 square root of 2, which is the same thing as square root of 8. So use inside triangle to build, I said that wrong, use the inside of the parentheses to build the triangle, and then the outside to read. So this outside function you're going to read off from here. So if I build this one, cosecant, you could use this information here, hypotenuse over opposite. But if I build this, then this would be the same thing as having the sine of 2/3. Sine of 2/3 means this, and so hypotenuse over opposite. Build my right triangle, find this missing piece. This would be 9 minus 4. And so I get the square root of 5. And then I read off the cosine. Cosine is going to be adjacent over hypotenuse, so it's going to be square root of 5 all over 3. That's how you do those. Okay. Now to the calculus. What we have are some different rules for the arc sine, the derivative of the arc sine. And then we have the derivative of the arc cosine. Arc tangent, cotangent, secant, cosecant. All those are the inverse functions. So when we take the derivative, we get these different values. Now if you look at these are very similar. They just differ by a negative sign. These are very similar. They just differ by a negative sign. And then these are the same except for they differ by a negative sign as well. So memorizing these it's not too bad, but you have to go ahead and do that. Now let's do a proof. And actually I'm doing a proof of arc cosine of x. So if I let y equal the arc cosine of x, what I can do is I can flip-flop this around. Since they're inverse functions, this is just switching x and y around. So it was x equals cosine of y. We're going to do implicit differentiation. The derivative of the cosine is the negative sine of y, and then don't forget to chain. We get dy dx. Solve for this, and we get dy dx is equal to negative 1 over the sine of y. Now I guess we could leave it like this, except for we want this in terms of x, if we can. And so if I take this, the sine of y, y is the arc cosine. And so I'm going to have to go over here. And so I'm going to get negative 1 over the sine of the arc cosine of x. I just replace this y, and here's my y here. And this is equal to dy dx. Now this looks very similar to what we just did. In fact it is. So I'm going to build my right triangle with my theta. Arc cosine we build is going to be adjacent over hypotenuse, so this would be 1 minus x squared would be this side. So the sine of the arc cosine of x is just going to be square root of 1 minus x squared. So dy dx is going to be equal to negative 1 over square root of 1 minus x squared. All over 1, but I ignore the 1. I don't need that. So there we go. So that's the proof. And then with these, since they're a function with u, then we have to chain off the u. So if we use some of these rules, let me do this screen bit here. So let's try some examples. This one here, we have the arc sine of 4x, so that fits this pattern right here. So if I want to do y prime, that is equal to 1 over 1 minus u squared, so it's going to be 1 over square root 1 minus, and then put the 4x in parentheses and squared, so the 4 is going to be squared as well. Then chain off the 4x, I'm going to get 4. And so y prime is now equal to 4 over the square root of 1 minus 16x squared. Done deal. This one, 4 arc cosine of x over 3. This one's going to take some simplifying later on. So y prime, this 4 goes for the ride. And then we got arc cosine of x over 3. Arc cosine is this one here. So I'm going to get a negative, and it's going to be 1 over the square root of 1 minus x over 3 squared. And then I need to chain this off, and so I need to multiply by 1/3. If I simplify this one a little bit more, I'm going to get negative 4/3 times 1 over, I'm going to get a common denominator here. So this is going to be 9 down below, so this will be 9 minus x squared all over 9. So 3 squared is 9, and then 9 over 9 from here. And when I do this, if you notice, what's this, in this square root encompasses this 9 here, what's the square root of 9? Well, it's the 3. This is in, if I block out this top part, this 3 is in the numerator of the denominator. So this 3 and this 9 will cancel. Square root of 9 is 3. So I'm left with negative 4 over the square root of 9 minus x squared. And now here's one of those composition ones. There's 2 ways to do this. Let's do it as it is. Y prime, derivative of the outside function. Derivative of the cosine is negative sine. Leave the inside alone. And then chain. So if I take the derivative of the arc sine, it would just be 1 over the square root of 1 minus x squared. But what is the sine of arc sine? Oh, that's going to be x, and so I'm going to be left with negative x over the square root of 1 minus x squared. We may have a few domain issues there that we're ignoring, but we'll just run with this. So that's my derivative. Now if I did it the other way, simplify this first. Y equals, build my little triangle. I'll do this over here because I'm running out of room. This is theta. If I build my triangle, the sine would be opposite over hypotenuse, so this would be the square root of 1 minus x squared. So overall, if I read off the cosine, this is the same thing as 1 minus x squared. If I take the derivative of this, I'm going to get the square root function, so y prime is equal to 1 over 2 square root of 1 minus x squared, and then chain it off by a negative 2x. And if you notice, you're going to get exactly the same thing. Voila. My last one here is going to be, oh, I got a little product rule here. Nice. There's a product rule. So y prime is equal to the first times the derivative of the second. The arc cosine is this one here, so it's going to be negative 1 over square root of 1 minus x squared. So that's first times the derivative of the second, and then I go plus the second, which is the arc cosine, times the derivative of the first, which is times 1. And then I'm going to have this derivative here, which is negative 1 over 2 square root of 1 minus x squared times a negative 2x. Those change, and so I'm left with this. These 2's cancel, and so I'm going to have negative x over square root of 1 minus x squared plus arc cosine of x, and then plus x over square root of 1 minus x squared. Oh, look at that. These 2 cancel, so I'm left with the arc cosine of x. So the question is, why would I do this? Well, let me ask you, what is the integral of the arc cosine of x now? And that would be equal to what I started off with up here. So that's another way that people find antiderivatives, is through finding these derivatives. So summarize yourself, and then there's the homework. Thank you.